In this video, I want to give an introduction to sequential logic circuits. So far in the circuit that we saw, we work with combinational logic circuit. In combinational logic circuit, the outputs of the circuit is always dependent on the current values of the inputs. So even though we may have some delays for us to see the effect of changing the inputs at the outputs, but nonetheless, we don't have any connection between the outputs at the current time and the previous outputs. So on the other hand, for the sequential logic circuits, the outputs of any sequential logic circuit depends on the current values of the inputs and also the prior values of the inputs. So in another word, a sequential logic circuit, they have memory. So that is the main difference between sequential logic circuits and the combinational logic circuits. So based on this, let's just go over some definitions that we will be using in sequential logic circuits. The first definition is the definition of a state, which is basically all the information about the circuit that is necessary for it to, for us to be able to explain its future behavior. So that is what is called a state. So for example, a clock is an example of a sequential circuit. So if we know what is the current time, we know what is going to be the next value for time. For example, if we assume that we are going second by second, if I tell you right now the time is 10:55 and 44 seconds, you know that the next one will be 10:55 and 45 seconds, right? And then from that, you can tell the next state. So that is what is called a state. So in order to be able to store the sequential logic circuit states, we use latches and flip-flops. I will go over them in more detail in later videos. So latches and flip-flops, generally, they are called state elements that can store one bit of state. And then the final definition that I want to go over is the definition of synchronous sequential circuits, which are basically a combination of combinational logic circuit followed by a bank of flip-flops or latches, to be more general. So we will go over later on how we can design these type of circuits. But for now, keep in mind that even for sequential circuits, we have still combinational components. But in addition to those, to be able to store the state of the system, we need to have a bunch of flip-flops for saving those states. So to recap, sequential circuits are used to give sequence to events. When I say sequence, that means that it is important what is the previous state. Because using the previous state and the current state, we can get what is the next state. They have memory. So usually this memory is short-term memory. And in sequential circuit, we use feedback from output to the input to store the information. So now that we know this, we can talk about a little bit more on state elements. So since the state of a circuit, or more specifically a state of a sequential circuit, influences its future behavior, we need to have state elements to store that state or store the current state. So in the next few videos, I will go over these four types of state elements. I will start with bistable circuit, which is the simplest form of memory. Then we have SR latch or set reset latch, then D latch, and finally D flip-flop. Of course, these are not the only latches and flip-flops that are used in practice, but when you learn these things, you have a better idea how to analyze those other types of latches as well.